So I thought today we'd build a pin walking robot together with 3D printed parts. In fact, two of the parts are still printing. And pin walkers is a term used by toy robot collectors, but it's really a push rod. But if you've built any of the other robots that I've put up on Ting-I-verse, whether they're the servo controlled ones or whether they're the 3 different clawfoot walkers, then you're kind of familiar with it. In fact, the last one I put up there, the Rocky 5, drone number 5, that's a pin walking robot, even though the body rocks on that one. So in this particular one, we'll start with this mainframe piece. And on this piece we're going to put the motor, the gears, the battery pack, and the on-off switch. And this part prints flat like it's sitting on my hand on the bed. No supports required. In fact, on my printer, the MK3, there weren't supports required on any of the parts except for this arm lever, because it prints in this direction like it's resting on my hand. So supports are required on the bottom part, but they fall right off. So other than that, I didn't require any supports. If your printer has poor bed adhesion, you might require, who knows, I don't know, you might need a raft, or maybe you'll need a glue stick, or who knows. But I didn't require any of those things to print these parts. So to power it, I'm going to use one of the cheap motors. It's a dual axle. You can find them everywhere: eBay, Banggood, AliExpress, GearBest, all those places. These came from China, and it took about 3 weeks to get here. I think these ones came from GearBest, and they were about $1 a piece. Pretty inexpensive, but you can find them on eBay for more money, and you can find them from local sellers. In my case, I'd be in the USA, where you'll pay $3 or $4 a piece for them, but at least you'll get them quicker. But this is going to be the heart of our project, and so this one part, I use a little bit of glue to hold it into this cradle. It's going to fit in like this. Just sits back against this wall. But to make sure it stays there, you could use hot melt glue. That'd be really quick if you're trying to put together, and I guess if I had a hot melt glue gun around, I would. But for right now, I'll just stick some goop on there, and we'll see how that goes. It may not be dried in place by the time we're done with this project, or it might be. But that's going to sit like that, and I'm going to use a it's a AAA battery, but it's 2 cells. So a double AAA battery holder. And this particular one came from the Pololu website, because I was ordering some of their controllers for a different project, and that was when I ordered this. It's probably very similar to all the ones that you would buy off eBay. If it has the hole in the middle, it'll probably fit right in to this design the way I have it planned out. I'm going to use a short number 2 self-tapping screw. And I think, just to make sure it doesn't do any twisting or turning later, I'm going to put a couple of dabs of glue on the back side of it. And it fits right onto the back of this. There's already a hole provided. And what did I do with my little screw? Okay, like this, that. And there we go. So you can see it sits all the way down on the base. It's right on the back. Wires are just going to stick out the top for now. And let's see, we can do a little bit more prep on this part, I guess. I have a small switch. Again, just bought them off eBay. And normally you have to get the little 2mm screws separately. So I normally just, because they're inexpensive, same time I order the switches, I'll order a small bag of 100 of these little screws so I have them around. But you're going, well, what size slide switch? Well, once you print the part out, you'll be able to measure between the mounting holes, and then you'll know what size. And I just dropped one of the little screws. There's holes provided. See if I can find the one that I heard make an exit. I think it bounced off of me. Oh, I hear it on the floor. But I might not ever see it, so I'll just grab another. For example, this would be like a little baggie full of them that you can buy really cheap. So you have supplies around, the machine thread, that, and there we go. So now we have our motor, our battery pack, and our switch all hooked on to the main motor frame that everything else kind of hooks to. And I did hear the printer to stop, so let me grab the last two gears off of the printer. These are the same two gears that I've used on all of the clawfoot projects, so if you've built the type 1, 2, or 3, this small gear and this motor unit are the same. And it fits onto the double D shaft, like so. And you really don't need to screw it or glue it or anything, but I do like to take, simply because I have them, take a screw, and then I know it's never going to move. This is a number 2 self-tapping screw, and just feed it in the end, and the head digs into the gear. You want the head recessed in so it doesn't hang up on anything. Like so. There we go. Alright, so far so good. I'm going to let that set up a little bit, and we'll just do a little prep somewhere else. So on the arms are going to move as the robot walks, and this is one of the arms. I designed all of these parts in Design Spark Mechanical, which is the program I prefer to use. And this little lever will be on this body, which I already did some hand painting on. This prints as one piece, by the way, upside down like you see it sitting in my hand. The hand prints the same way, laying flat. This part we already talked about. It's the only part that required some supports. This will be on the inside, going through that armhole. And then, of course, the arm will be on the outside. And then I use a long number 2 self-tapping screw. I think these were like a ½ an inch long. They didn't need to be that long. That's just what I had, and the extra length doesn't hurt anything. And so what you have now is, if you move the lever on the inside, the arm on the outside will move. And the black lever, if we can get this so the camera can see it for you, the black lever is basically in line with this part of the arm. Okay, and we'll just do that on both sides. So let's take that one, take that one, make another long screw. Now, if for some reason you didn't have the long screws and you wanted to put the thing together, you could just cram a piece of wire or something through there to line the two parts up and put a little glue on there and glue them together. You would just have to be careful that the glue didn't bond into the arm parts to the body, because you want all this stuff to swing freely. So let's again, let's let this glue set up a little more and let's talk about the head. The head on this unit is printed in two parts, a front and a back, and they both print laying flat like you see them right now on the table. This one, again, I've done a little bit of painting on it. And on the very top of the head, when the two parts are glued together, which we're going to do here, there's a place for a dome. So I printed this dome, which is in a translucent green in my case. And because I wanted the dome to light up, I took a green LED. It's a top hat ultra bright LED. And if you've worked with LEDs, and you know that normally the longest leg on the LED is going to be your positive. In this case, that'd be the red wire. And the shorter leads your black. Or if you don't have a long and a short, then if there's a flat on the LED, the flat side's your negative and the non-flat side's your positive. And you do need to put some sort of current limiting resistor in there. It doesn't really matter what kind of resistor. I mean, it could be anywhere from a 33 ohm to a 220 ohm. It isn't going to make any difference in our particular application. We're working on a 3 volt supply, and red and green LEDs of the new type that you buy these days are going to ignite. Their conduction current is below 2 volts. So you need a little bit of current regulating going on there so you don't fry the LED. And again, it would only change how super bright it is, but already they're plenty bright for the indicator that we're going to be doing. So I'm going to take these two halves, and because I'd already glued in that LED ahead of time so I wouldn't have to deal with it now, that's already sitting in there and the wire's already fed out. I'm going to put a little bit of a extra thick super glue in a couple of key points. Cap that. And I think I've got my parts lined up. And when you're sure you got them lined up, then you just use your zapping stuff, your quick set. Hose it down a little bit. I'm holding it here just to make sure. I was off a little bit on this side, but not too bad. That side looks pretty good. Like so. Then this whole headpiece is going to get glued onto the top of the body in this sort of fashion. So it looks like this. So let's do that. I'm going to put a little bit of glue around the neck stem, let it do most of the work, and dab just a little bit on these cosmetic parts. I think that's where I want it. Zip that away and then spritz it with some of the quick set. So we now have that prepped. We might as well put the dome on there. Get that out of the way. I'll put a few drops. Then gonna need much. That was probably way more than it's gonna need. Set that on top, semi-centered, and of quick set that. Okay, so we now have our body prepped. We could, I guess, let's talk about the legs, the feet, and the push rods. The push rods themselves, because this is you know, PLA, hard plastic, if it's on a surface, it's going to be very slick. And when this push rod comes down, it moves in a circular motion to make the robot move forward. This is too slick. So I have this little teeny O-ring in my hand. Maybe you can see it. And they snap right in like that on the ends of the push rods. And basically you can buy O-ring assortments from places like Harbor Freight. They got kits for under $8 that have like 380 some odd O-rings in there of all different sizes. It's a very handy kit to have around if you ever want to add traction to any plastic wheels or things like this. So for the small amount of money that they cost, they're well worth having. Most pin walkers, and by the way, when pin walking toys, some of the earliest robots like Lilliput, Atomic Robot Man. Lilliput's in the 1930s, Atomic Robot Man, earliest dead I think is like 1947 through the 1950s. They're very small. They weren't, the whole robot wasn't much taller than this leg. They were wind up and they used this, what we like to call pin walking design. They would have fixed feet to keep costs down, where the feet and the leg don't have any pivot. They're solid and they just let it rock up on the foot. That actually works fine. I like to add a pivot to the foot, so when the push rod on one side is lifting the robot, that the foot on the other side can stay completely on the tabletop surface and the leg can pivot. So in order to do a pivot like that, we're going to be running some small number 2 screws in through these holes in the bottom of the leg, which then thread into these pivot points on the feet. And I really don't know, since we haven't put this thing together, except for right now that we're dinking around with it, whether it makes more sense to put the feet on now or put the feet on later. So if it's wrong, we'll just take them off. But we'll put them on now and see how that goes. I'm not sure that I can do this in stay in camera at the same time, but basically I'm going to take this screw, and there's this, start with the leg, this round part goes to the front, there's a hole, so basically the idea is to get it through the hole like that, and you need a long screwdriver, and then you would want to get your foot on there and screw it in. And again, like I say, I'm not sure that I don't really think I can do this and stay in camera. I kind of need to push this part against my chest, and even then I'll probably drop the screw, but we'll see. I'm going to try and keep some of this in camera, whatever I can. Okay, hit the hole finally. Put that one on there. And it does help if you have a screwdriver whose tip is magnetized, because it can help hold the screw as you're trying to feed it down in there, like so. But you can see now the foot can stay level if the leg were to move, which again, like I said, isn't critical to have. I just think it makes the toy work a little better. Definitely makes it look nicer. There we go. Let's try it again on this setup. That. And not too bad once you've done a couple of them, I guess. You kind of figure out how to do it. Like I said, it doesn't really matter if you tighten them up all the way or don't. It'll work either way. But we'll see. Okay, so now we have our feet assembled. The legs actually will glue right into the bottom. Okay, they have a lip and that, so we'll put the super glue on there and we'll slot them right in there. This motor sticking out, the battery's the back, so obviously the motor's the front. And like I said on the leg, this round part is the front. So the switch will be in the front. That helps orient things in your mind if you're building along with me here. So let's put some triple thick on here. Like so. And there isn't a left or a right, so you don't have to worry about that part of it. I'm hoping some of this is staying in frame, because obviously I can't be staring at the camera while I'm, especially while I'm gluing. Otherwise I'd end up gluing my fingers or the table, and that would go over really, really big with the missus. Okay, take this one, put it on. I'm going to cover up my glue. Starting to look like something now, isn't it? It is to me anyway. I realize you're getting a bird's eye down view, and I'm getting a more appropriate side view. But basically we now have legs attached to the motor frame and feet attached to the legs, like so. Set that there. There's the two gears, and to hold the gears on, just like in the other videos where I did the type 1, 2, and 3 clawfoot walkers, I'm using a number 2. No, this was a 3 by 12 millimeter, I believe. Yes, but you could use whatever you got laying around. If you're in America and you don't have any of that and you don't want to order any of it off eBay, then you can probably find things at the dollar store you can rob screws out of, or you can probably use a 440, which is a common machine screw, and accomplish the same thing. I'm going to use a small washer as a spacer. And then there's these upper holes just above that. And I might as well line things up a little bit, because we have to have the gears on either side 180 degrees out of phase with each other in order for the thing to walk. Guess I'm doing good. I'm going to tighten it all the way down so I know it's bottomed out, then loosen it back up, because you want to know that the gear can turn free. And I had that one with the post down, so when I put the one on this side, I'm going to want to have it with the post up. I probably should have cleaned the holes out in these gears a little, but I think it'll wear in. I think it'll be okay. So this side will be post up. Then back it off. I tightened it up all the way and then backed it up. Okay, so we have our drive gears set up, and I believe we have post down on one side and post up on the other side. I think we're sitting pretty good that way. Probably would be a good time to do a little bit of the wiring. I'm going to take the positive wire and I'm going to attach it to this side of the motor. The negative wire, there's a piece of plastic that holds these motors on. You can feed wires through them, which is kind of good for cable management because you don't want any of these wires getting caught up in the gears. So I kind of fed that through the plastic, then it's going to come down to the switch. So let's cut off the extra. And let's strip that back. And let's do a little bit of soldering on the switch first. Let's get those all ready, get a nice coating of solder on them, then tin up the wire ends. Sorry, I can't do much about the camera angle here. It takes both hands to hold the wire and the soldering gun, so you may not be able to see much as I'm hooking these on, but I'll move the part closer to the camera. You can see I just attached the black wire to one of the parts of the switch. Doesn't really matter which one at this point. And I'm going to try and solder the red wire onto the motor. Looks like it's on there. Then we had, I wonder if this black wire that we cut's be long enough. Looks like it would be. So the remaining little piece of the black wire that we trimmed earlier will make the final connection from the switch back up to the motor. Since I have the other wire on one side, I'll put this black wire onto the center of the switch, like so. And I think I'm going to pre-tin the motor connection this time. Make it a little bit easier for me. Like so. Okay. So we have from our battery pack running up to the switch, then from the switch to the motor, and the red from the battery pack to the motor. And actually these battery packs have these little wedge pieces to help hold the batteries in. They're not really necessary in this particular case, and they'll just make it really hard to get batteries in the toy. So I'm going to bend these pieces of plastic back so it'll be easier to put batteries in and out. I mean, if you were doing something where a lot of vibration or there was a chance that the battery might fall out and that was like critical to the operation, I would leave those alone. But this case, it's not. I'm going to go grab a couple of batteries and we'll give that a test. Okay. Just to see if we're good so far. coming in there. These new little AAA batteries, it's really hard to tell the negative side from the positive side. I mean, they do mark it on the wrapper, but there's a button on both ends, so you can't just go by the button and think you're putting them in right anymore. So that's in, oh good, the motor runs, the gears are turning. That's very good. So let's put the cranks in that we talked about earlier. Now you'll notice that besides the little rubber grommet that we put on the end, there is a build-out loop there. That's a spacer to help hold it in place inside the leg channel. And this strange flag part, this is part of a circle. If you imagined in your mind that continuing around, it would be a full circle. Well, we don't need the full circle for this to become a pivot point because it's only moving so much. So I only kept part of the circle to save plastic and print time. There just wasn't any reason to print it all. But what this does is this keeps this push rod centered, so this forms a pivot point inside the leg. So as the crank that we're going to attach this end to up here is moving around in a circle and pushing and pulling, see, it does two things. The crank, as it goes up and down, raises and lowers the post, but as it goes round and round, it makes it tip. So that's how you get your forward or backward walking. You could in fact use a different switch and have a forward and reverse. The toy will walk backwards just as well as it will walk forward. So now we're going to fish this part in with those two screws there. You kind of kick it a little bit sideways. I'm going to bring it up and I'm going to pop it over the post like that. And you probably wouldn't even need to screw it. I don't think it would come out on its own. But again, like I did on the clawfoot walkers, I just take another number 2 and a small flat washer, and there's a place provided to screw it on. And once you do that, then there's, you know, no chance of it ever coming off on its own. This screwdriver doesn't really seem to be fitting that screw really well, so I'm gonna hold off on tightening that down more. Let's put this one in. Again, the wedge part that we talked about, facing towards the out. Kick it a little bit sideways till you get past the two screws. Get up on there and just pop it on like that. And let me find my other screwdriver. I think it likes those screws better. There we go. We'll see anyway. The screw, washer. All of these files will be up on Ting-I-verse. If they're not up there right now at the time of you viewing this, they will be up there shortly. We'll see when I go to publish this how all that goes. Okay. So if you wanted to design your own body and you just wanted to keep this as a walking base, this is all you would have to build. You wouldn't need to build anything else. So at this point, again, you're looking down at it, I realize that. But basically, you can kind of see how the cams move and come around, and that forms the walking action. So that's all working just fine. Now, what makes the arms move in my design is there's these posts, as you saw earlier, and if I put the body on, if I hold it face down like that, so the arms are sticking out the front, and when I put the body on, then they'll be in front of these push rods. And when you set everything down, gravity will make them come down and contact these push rods. And since these push rods move back and forth, as well as up and down, the up and down won't be moving the arms, but the back and forth point gives those arms, that pin off that lever on the arms, a place to travel, and that can make the arm move. The light. I'm thinking I'm going to shorten this wire. And we'll solder that LED for the dome light right across the motor and try to stuff the wires up into the head so they don't get caught in the gears. Anyway, that's the plan. This, like I say, this hasn't been tried yet. We're doing this together. It's just been designed in my mind. So let's take this. Lay these parts down, maybe, huh? I'm sorry that you can't see anything. I don't have a camera person. As you know, I don't edit. I always shoot everything live. Quite frankly, I do this for fun and to share and for education, and editing is too much like work. Kind of sucks the fun out of everything. Alright, so I think that it's all connected, and having never tried to cram the wires up in there, I haven't figured this out yet. Let's see if we can... I was thinking that if I got them started, then they would just keep feeding themselves in as the part goes in. Let's see, this goes this way though. I had the front to the back. That would never do. Okay, wires are going up into the head. May not be the best design. I do have an alternative design that might be better, but look at that. I got the two halves of the head together, the arms there. Whew, the dome light lights. You know, the arms are moving. And you're going, well, what holds all that together? Well, I provided holes in all corners to add screws. And that one seems unnaturally long. I'm going to go ahead and try it. But if it doesn't work, then we'll take it out. No, it worked. And of course there's no real reason to actually put 4 in. I mean, I'm going to go kitty corner right now to save time for everybody watching. There we go. So now it's held together on its own. I think what I'm going to have to do is manhandle the camera so that we can get a shot that you guys can appreciate of this guy walking here. I'm trying to get some power cords out of the way, stuff like that. And hang on everybody, you're going to be jerking around. And I'm grabbing the tripod. Okay. Hey, here we are. Let's turn this bad boy on. And there she goes. Walking, swinging arms, lit head. And you can build one. You can 3D print the parts. There's the MK3 that I printed all the parts on right there. And you can get to the batteries to pop them right out. So, go out, do, enjoy, share, learn, have fun, 3D print. See you later.